T minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Main engine start, 0. And liftoff of the Atlas V with Curiosity, using clue to the planetary puzzle about life on Mars.
Good morning, I'm Keke Palmer, and I'm coming to you live from NASA's Jet Propulsion Laboratory in Pasadena, California. Here at JPL, some of the sharpest minds on the planet work every day to connect us to the sharpest minds on other planets. They make robots here, space robots that travel to other worlds. In a moment, we're going to chat with a member of JPL's Earth-based crews. But first, let me tell you what the program's all about. Our focus today is on you and your future. Some of you have ideas about what you might want to be when you grow up, and some of you are still searching. Well, today, we're going to help you by taking you to some of the coolest workplaces in the world. We're going to give you a taste of the many incredible possibilities there are. We'll talk to you about some people and their dream jobs as they show us around the state-of-the-art facilities they call the office. These folks love what they do, and you're going to get an inside look at what they do and how they came to do it. There's a key word you're going to hear repeatedly today that I want to define for you, and that word is STEM. S-T-E-M. That stands for science, technology, engineering, and mathematics. Fields that play key roles in the world around us and everything we do. Now, STEM isn't the only term you'll hear. You'll also walk away with the words iON Future pinging in your head. iON Future is a set of online free learning games. They're fun, and they tell you a way to explore exciting jobs in STEM. But more of that later on. Right now, I want to give a shout out to our audience. They're here from John Muir High School's Engineering and Environmental Science Academy in Pasadena, California. All right, you ready to blast off, everyone? Yeah. Yes, I like the enthusiasm. Say yes again. Yeah. Let's get it going from right here at NASA's Jet Propulsion Laboratory in T-minus 5, 4, 3, 2. First set foot on the moon in 1969. The Jet Propulsion Laboratory had already been in space exploration business for years, but they don't send people into space. They send robots. In 1958, JPL designed and built Explorer-1, the first U.S. satellite and the first spacecraft to relay data back to Earth. Before NASA even thought about sending a man to the moon, JPL first sent an explorer to the moon called Surveyor. In fact, they've also sent exploration vehicles to Neptune, Venus, and Jupiter. There's no place these guys don't go. Of course, JPL's latest triumph was the landing of the rover Curiosity on Mars, which occurred this past summer. Right now, we're going to meet the flight director of the Curiosity mission and someone who can tell us about what goes on here at JPL. Bobak Ferdowsi. What's up?
Hey, how's it going?
Very good. Is it safe to say that you tell Curiosity what to do? Like, go there, Curiosity. Pick up that rock, Curiosity. Not that one, that one.
It's not exactly like that.
Well, what can you tell us what goes on here at JPL?
So we actually work in this area of robotic exploration. We're exploring both the planet Earth and the solar system around us. We've got missions at all sorts of different planets, and even one that's on its way out of the solar system. So that's kind of what we work on here.
What made you want to get into a career like STEM or working here at JPL?
You know, I grew up playing with Legos and building things and just trying to ask questions about how the world works. And you know, one day I sort of realized that there's an opportunity here to do that kind of stuff, so to go understand the world and to kind of explore and build even cooler things that land on other planets.
Okay, now I have a really personal question. My sister and I always have this question. Maybe some of you guys might want to know too. But will people ever be able to live on Mars? Like, will that ever happen?
I hope so. I think with curiosity, we're trying to understand the environment of Mars. We're looking at radiation and weather and things like that. So it's the kind of things that humans need to know when they're going to live on a different place.
Okay, I think it's safe to say you got one of the coolest jobs in the world. And I like your haircut. Okay, now it's time to send you to another location halfway across the country. We're going to hear about the exciting work people do every day and about some of the challenges they face part of their work. As you'll see, these challenges can be tricky, but you'll also see how these challenges can be tackled by using creativity and their STEM-based knowledge. Watch now how they do it, because later in the program, we're going to ask you and your STEM knowledge to tackle one of these challenges. Our first destination is another hotbed of precision engineering, the on-wing care facility for Rolls-Royce jet engines. Hello, Indiana.
Hey there, Pasadena. Did you know at any given moment there's around 400,000 people on an aircraft powered by a Rolls-Royce engine? Well, I'm Leland Wheeler, and here we are at the Rolls-Royce On-Wing Care Facility in Indianapolis, Indiana. Reginald, thanks for having me.
How you doing, man?
I'm great. Where are we?
Where are we? We are at Rolls-Royce right here in Indianapolis, Indiana.
And what do you do here? I don't see any fancy cars.
Exactly. We make a gas turbine engine, a jet engine. See it on a helicopter, airplane, you know, cruise ships. Next time you're outside, look up in the sky and you go tell somebody, man, I just saw a Rolls-Royce, right? How did I see a Rolls-Royce? That engine on that airplane. So here in Indianapolis, we got about 4,000 people work here, 1,200 engineers. We use science, math, teamwork, a lot of communication to make this wonderful product.
Hi, we're here with Mike Webb, design engineer. We're standing in front of a combustion engine.
Correct, a gas turbine engine.
A gas turbine engine, and you design what part of this?
I design the parts at the back of the engine, so the hot parts in the turbine.
What are you holding in your hand there?
Right, so this is actually a turbine blade from a Trent engine. We have aerodynamicists, we have thermal engineers, we have stress engineers. All of that is going to come into my design and make it work. But I have to be the integrator of that team to make it all work. So I have to understand how hot that's going to be, and is that going to affect this part of the engine, and is it going to melt that section? So I need to bring in all the data together and then come up with the final design.
All of this is very overwhelming, and you didn't start off designing engines. What in middle school and high school helped you stay focused?
I've always been a car guy, and I guess through middle school and high school, I've always been interested in how they work. I mean, it starts off and you're just in a classroom, you're learning numbers, and I guess at the time you think, well, how's that going to work? But as you progress through the education, you understand how all that integrates, and then it starts making an airplane fly. You know, that's how it works.
I'm here with Masha Tolstik. She's an aerodynamicist. What initially made you want to be an aerodynamicist?
So when I was little, I really wanted to be a cosmonaut. I grew up in what was then the USSR, and I really wanted to travel to the moon and travel to the stars, and really wanted to learn what makes things fly. And so I went in to study aerospace engineering and really fell in love with the fact that you could simulate anything.
Do you feel like you need more female engineers out there?
Not really. I mean, we're definitely underrepresented right now, but you see a lot more girls starting to go into it. And the thing is anyone could go into engineering. I didn't grow up playing with Legos. I grew up playing with Barbies and combing their hairs. But I found that I really liked math and doing the math equations and solving the math and the physics equations, and that's what really got me interested in going into engineering and aerodynamic engineering.
I hear you have a challenge for us.
Yes, we do. So you've seen all these wonderful parts today to make up this wonderful engine, correct? So a typical gas turbine compressor squeezes air down 50 times its original size, right? Kind of think of it like your parents' car, and you squeeze it down to like a little Hot Wheels car, because we're trying to make that air hotter. From there, we even need it even hotter, right? So now we send it to the combustor. We add a little fuel, burn it to make it even hotter. From the combustor, we send it to the turbine. At the turbine, that temperature is 400 degrees hotter than the melting point of that metal. We have to keep those metals in the engine cool enough that they don't melt. Almost like trying to keep an ice cube intact inside of an oven. So here's the challenge. How do we keep a metal from melting at 400 degrees higher than its melting point?
Really good question. How do you keep a piece of metal from melting when it's 400 degrees hotter than its melting point? It's pretty important when we're talking about an airplane. To solve that problem, the folks at Rolls-Royce came up with some interesting ideas based on STEM. To keep the metal from melting, they move cooler air from one of the part of the engine to where it's getting hot. Another solution is to create holes in the hot parts to allow cool air to flow through them. A heat protective paint also helps part withstand intense heat. A lot of very good and different STEM ideas. Your chance to use your STEM thinking is coming up. Moving on to another location where STEM knowledge is used every day in every way. Hello, GlaxoSmithKline in Collegeville, Pennsylvania.
What's going on, everybody, over in Pasadena at the Jet Propulsion Laboratory? I'm GK Williams, and I'm here to welcome you to GlaxoSmithKline. And let me tell you, a lot of cool stuff happens in here. You want to check it out? Yeah, I know you do. Come on, follow me. Ah, you like that, right? That's science. All right.
Hi, my name is Stan Martens and I'm a scientist working at GSK. I'm a manager in the compound and screening and compound profiling group, and my role is to find new starting points, chemical starting points for new drugs that we want to bring onto the market.
A lot of our future scientists and researchers that are viewing right now may not be all that familiar with GlaxoSmithKline. So if you could briefly just describe some of the products that are from GSK.
So the type of stuff that you can just buy at the supermarket is, for instance, Aquafresh toothpaste. Right? Everyone knows probably Aquafresh, and you can just buy it here. And there's a lot of drugs that you cannot buy. You have to actually go to a doctor and get a prescription. Augmentin is one of them. It's an antibiotic, so when you have strep, or you don't feel well, you have an earache, sometimes your doctor will prescribe Augmentin, which is a GSK drug. And then there are things like cancer drugs, like Tyker. And there's also vaccines, all kinds of cancer vaccines that GSK working on or has on the market.
Right now I'm with Leanne Inken, another great scientist here at GlaxoSmithKline. How are you doing today?
Hi, good, thanks.
All right. Well, you have a lot of cool stuff in your area. What are you doing today?
Well, today I'm using DNA to transform E. coli. So here's the tube of DNA, and I'm going to use that to put it inside these cells.
Okay. And then what happens next?
Then I put those cells on this plate and grow them. Eventually those cells are going to make protein.
Okay. How long have you been here at GSK?
Actually, today's my 1-year anniversary.
All right. Congratulations.
Thank you.
And in your 1 year here, what's the most gratifying piece of data or anything that's happened here so far?
Wow. In the 1 year here, I think the most rewarding part is being a member of a team and solving a really difficult problem. So at GSK, we make medicine, and it's really rewarding at the end of the day to have completed a project to make a medicine.
You love this stuff.
I love what I do. I love my job. I'm really lucky.
All right, that's all you can ask for. Leanne, thank you so much for your time.
Thank you.
Now here with my man Jeff Quinquay. Jeff, how you doing, man?
Good, and you?
All right, good day. It's a good day so far. So, what's your official title?
So I'm an associate scientist here at GSK.
All right, and what happens in this area here?
So within this lab, what we do is we screen drugs. So by screen, we mean we just test them. So we test 1.9 to 2 million compounds against any kind of a target. And it targets any kind of disease that we want to either stop or treat. So that's what we do. We test a whole bunch of drugs, and we finally get to one drug that can be tested even more and more until we optimize it. So it can be given to a patient. It doesn't make them sick when they take it. It makes them feel better.
All right, sounds cool. Now, did you always know that you wanted a career in STEM?
For the most part, yeah, I actually did. So it kind of started back when I was in middle school and high school. I really started taking the math and science courses, and it was really from that I really enjoyed it. So that's how I kind of got on this track.
All right. Was there anything from those physics classes or math classes or biology, chemistry classes that you have to directly apply to your typical day here?
Oh, absolutely. So I mean, some of the stuff that we learned way back when, dilutions, just basic math. I mean, it's the basic things that you kind of come back to. It's the problem-solving skills from when you take science courses. So not necessarily just the core material or the textbook material. It's the thought process behind a lot of it.
All right. You heard the man. Jeff, thanks, man. Always a pleasure.
Thank you.
All right, no problem.
All right, young scientists, I got a problem, a challenge for you guys. We have 2.5 million potential drugs that we have to test in our biology to find cures for diseases. So we can transfer these drugs by hand using a pipette or have a machine with syringes transfer these from one plate to another plate. But there's a lot of problems with that. There's a lot of waste, we got to rinse, a lot of problems. So how would you transfer a drug from one place to another place without physically touching it?
How do you transfer a liquid without touching it and without spilling it? The disease-fighting compounds that are being measured out have to be exact and have to be very, very tiny. Hands can't touch them. And scientists don't know which compounds will work. To answer that challenge of the testing, many compounds in small amounts, the folks at GlaxoSmithKline use an echo machine. This machine uses a sound wave vibration to transfer a very small amount of liquid to one container to another. So, using their STEM-based knowledge of how sound waves work and the properties of liquids, another tricky challenge was solved. See how they did that? Your chance to use your STEM-based challenge, well, your STEM-based knowledge, is coming up. Right now, let me transport you to another location, the headquarters of Global Entertainment Goliath, Viacom, and home of your favorite, well, your favorite everything, basically. Viacom's important to me because they show my show, True Jackson VP. It's on Nickelodeon, one of the Viacom's many networks. I bet you didn't know that STEM has a lot to do with how you get to watch your favorite TV shows. To find out how exactly that happens, we need to fly across the country. Hello, New York.
Hey, Pasadena, I'm Jessica DiGiovanni, and I'm here in Hauppauge, New York at the Viacom Network Operations Center. And if you like TV, then this is a place to be. Hi guys, I'm standing outside of Master Control, where Viacom has all its television channels that they send all around the world. Paul's going to tell you a little more about that. Paul?
Hi, I'm Paul Sartain. I'm the Chief Media Technology Officer for Viacom. So how does STEM play a role here? Well, science. As you'll see, we have to look at things like weather and see how weather is going to affect our signal. Technology. You'll get a tour around the facility and you'll see how much technology we have to deal with here on a regular basis. Engineering. When we talk about putting signals up over satellites, we have to build an infrastructure to be able to transmit those signals up to the satellite. And math. We use math every day, whether it's trying to figure out how much cable we would need to build out a new network, or when a live show, like the VMAs, runs late and we need to hit the next show at the top of the hour. We use math to try to figure out how to do that.
Luis, can you tell us a little bit about what you do here?
Sure, I'm an operations supervisor at the facility. I'm in charge of a team of about 20 people. They run the networks, making sure that the networks and all the content start on time, that all the commercials air, and that we have all the content that gets distributed to your home so that you guys can view it.
Okay, so when you say content, what do you mean? Are those the TV shows that we watch?
Absolutely, I'm talking about videos, commercials, movies, all the shows that you guys currently see on all the Viacom networks.
You have a lot of networks that you guys work with here. Can you name a few of them that you work with, some of the bigger ones that we might know?
MTV, VH1, Nickelodeon, Spike, CMT, Comedy Central is out of our facility.
Your company kind of schedules everything, right?
Absolutely.
You know, Teen Nick or whatever.
Right. We use a lot of math throughout the day to make sure that all of the commercials and the run times of these shows or videos air when they're supposed to.
Okay, so you do use math. You do
Absolutely.
use some of the STEM subjects.
Absolutely. Math is constantly being used in order for us to time out a day. There are 24 hours in a day, and we need to make sure that all of that time is filled up and every hour is accounted for.
So this will be on TV later on, like in a day or a couple of days, right?
No. 5 seconds.
5 seconds?
Yeah, or maybe a little bit more.
Oh,
What you're seeing now is being distributed from here up to the satellite. Whichever cable network you might have, they're getting that material from the satellite and then sending it to your home.
I mean, that's so crazy, guys. This is where it all happens, you know? This is how your show that you are probably going to watch when you get home from school is going to get to your television. And Luis here, just one of the many people who makes it happen. So, thank you, Luis.
Not a problem. Thank you.
Awesome. Lynette, can you tell us a little bit about what you do here?
Well, I'm the live events supervisor, and I oversee any live shows that air on MTV, VH1, Nickelodeon, Spike, CMT, and make sure they get on the air the way that the network actually wants them to get on the air.
What kind of advice do you think you would give to our future engineers and innovators?
In elementary and junior and high school, I would say that they should be well-rounded, and it's just important to be focused and just study and do as well as you can and make everybody in your life proud.
Hey guys, I'm here with John, and he's going to give you a challenge regarding the Network Operations Center. John, take it away.
Well, believe it or not, weather plays an important role in our ability to properly uplink the signal and get back to you uninterrupted. The intensity of the rain could definitely be a factor if it's coming down too hard. The amount of snow that can collect on the dish can interfere with the signal, and the wind speeds that we have on the dishes at any given time can affect our ability to hit the satellite. Those factors are definitely a concern to us and ones that we try to prevent. So the challenge to you is, what can we do to ensure that you can watch your favorite show even in the worst weather?
Another good question. How do you get a satellite transmission to reach to your TV no matter how bad the weather? You can't always count on good weather, but people want to watch their TV regardless. How are you going to get it to them? One of the ways that Viacom solves that challenge is by using what they call backup facilities, located where weather isn't a problem. It's a little like rerouting traffic around an accident or roadworks. Yet again, creativity and STEM-based thinking solved a tricky problem. Are you ready to track a challenge yourself? Good, because your chance to shine is almost here. JPL's Bobak Ferdowsi is back with us again.
Hey again.
Hey, Bobak. Okay, can we talk a little bit about curiosity and give our audience a chance to face one of the tricky challenges that curiosity may have challenged?
Sure. So one of the challenges we have, of course, is anytime we're going somewhere new, you can imagine just like Earth, you might have all sorts of different places that you might want to try. You might have icy places you want to go to, could be sandy, could be rocky. We haven't found this elsewhere yet, but you know, you could have lots of trees and vegetation around you. So you have to think about how you're going to drive or move around those places so you can explore those things. And so with Curiosity, we knew we were going to Mars. We've seen Mars before, but it's got rocks, it's got sand, it's got sort of hard terrain, and we needed a rover that could drive over that. And we also needed a rover that could interact with that. We want to like drill into those rocks, we want to zap it with our laser, all those cool things. So we had to design a rover that did that. And with Curiosity, we have this design that our engineers were inspired by trains in the world around them to have 6 wheels. And any one of those wheels can go up and down, but the whole body of the rover won't actually move. So that way we don't have to worry about falling over or sliding down anything while we drive around. Like if you put one wheel of your car up, the whole car would kind of tilt. So it's a clever design that we came up with. And then we have an arm, for example, to go reach out and touch some of those rocks and drill into them and then bring sample and put it back into the rover. So we're carrying all these instruments inside of us. And since they're so, these instruments are so complex, or the kind of things that labs have here at Earth, we had basically a 2,000-pound car that we took with us to Mars.
Wow.
Yeah, so it's those are some of the challenges that we face here at JPL in terms of designing a Curiosity mission.
Now, in designing a rover, does it have to be a box, or does it have to be a specific shape or whatever?
No, there's all sorts of things that you can do to make it work. In our case, the box works well because we're trying to put these instruments that are sort of boxy themselves inside there. But you could be in different types of environments. Maybe it's easier to float across sand, or maybe it's easier to, you might go to a watery place and you want to have like a boat design or something. Obviously, wheels aren't going to work very well there. So you have to think about where you're going and what you're going to encounter so you can understand what to design.
So out of all the things that are involved in STEM, what would have been in your time, which one of them did you have to use most in working with Curiosity? Was it science, technology, engineering, and math?
Yeah, we use a lot of physics, of course, in ours, and try to understand the different kind of angles we're going to be at, of course, and understand if you go a high enough angle, are you going to like slide back down, or are you going to? That's a cool video of us driving around. Yeah. But of course, like how we're going to even land the system, we have like a pendulum, and that's a real basic physics problem that you learn about. So a lot of physics, a lot of math, but of course the science teams, they use a lot of chemistry. So all sorts of areas we touch on.
Very cool, very cool. You guys think you might be ready? You didn't sound that sure. I'm asking again. Do you guys think that you are going to be ready? Yes! Yes, that sounds like it.
All right, guys. So for the next few minutes, you guys are going to take my job. You're going to be rover engineers. And I want you to think about all the different types of terrain and environments and places you'll encounter as you drive across Mars. You could see all sorts of hard surfaces. Could be loose sand, could be large rocks. So how are you going to get past those or over those or around those safely so you can actually explore the environment around you? So you have to take all that into account. There are no right answers, of course, but some might be better than others depending on what you expect to find. As a suggestion, maybe like our engineers, take some inspiration from the world around you. Look at other shapes maybe besides a box.
Are you guys ready? Yeah. Yes, let's take the next 2 minutes and put your STEM-based thinking to work. Let's see what you guys come up with. And I'm going to come around to a few tables, so make sure you guys get a little team leader that's going to be ready to show off your design.
Get cracking, guys.
Get going, get going.
We're definitely going to your table.
Yes, okay, so yeah, you're supposed to draw an idea of what you think of like a rover, what you think would be best equipped to go on, let's say Mars, like what you think would be best. It can be whatever, it can be round, it could be flat, if it lifts up, I don't know, whatever you know what I mean, whatever your imagination, and depending on what you want to do, like you said, you're trying to see some rocks, what you're trying to find up there. Are you trying to find out, is there water, is there life? What type of thing are you trying to learn, and you can use that.
Do you need to climb walls? Do you need to, drive over the desert? So think about that kind of stuff.
It's a live crew. What you guys doing?
Good. That's good. You got this.
Yes, need to move around. So one of the big things is that it has to think. So you can talk to it, you can transmit to it. And depending on where you're going, if we're going to Mars, let's say it's rocky there, right. I'll be trying to collect rocks. So does it
just
need
think
to
about
be
like,
able
if you were on Earth and what it would look like, like a place with
what
a desert
type of
and
things are you
rocks
trying
and
to
everything
do,
else out
and
there.
how can
what would you design to
get your rover
there?
set up to be able to do that? And it doesn't have, like you said, it doesn't have to be flat. I mean, it don't have to be any type of specific shape. Whatever you can think of, it could look like a person. Whatever, you know what I mean? Whatever you want.
Yeah.
What about you guys? What about you? What you think about?
You got this.
Very cool, very cool. What you trying to take up there? What you trying to learn or get? Keep thinking about it.
Well, let me ask you this.
Sky's the limit.
That's the thing. You know, what would you want to understand about Mars? And like sometimes
30 seconds, you guys.
Mars is a lot like Earth.
You better get to
What would you want to
moving.
know? What makes Mars different than Earth? That's one question you could ask yourself.
What about you guys?
What
What
would I
y'all
take
think
with me to
about?
the place? Like, oh, why is Mars different than Earth?
A big truck.
I got this.
Come on, you better draw a stick person, go. Do whatever you got to do. What about you? You like, I ain't even with it.
Going.
You better put your... All right, everyone. You see, even I'm like all caught up in this. This is exciting. I'm like everywhere. You both, Bobby.
Yeah.
We're both over there crazy. Okay.
Some
Now,
cool designs.
I'm ready to see what everyone has come up with. Anybody ready? Want to stand up, show off their design?
Nobody?
Almost. I see somebody work. Oh, look at, yes. Come on, let's show us. What is this? Explain. Please, stand up. Please. What's your name and what's this about?
My name's Jessica.
Okay, nice to meet you, Jessica. This looks pretty interesting. This looks cool. Tell us.
Here, let's see if we can show that to the world out there. You guys go. Yeah, describe it to us. Tell us what it's all about.
Well, my Rover is a triangle. I don't know why. I just like the shape.
Sure.
It has like a little fan or whatever to hover.
Nice.
Yes.
That's a pretty cool design.
It has like a little arm to collect the rocks and everything.
I like this.
Yeah.
I like this. This is very cool. And you got a nice wheel so it can sustain through the rocky, climate. I like this. Very good job, Jessica. Very good job. Oh, thank you. Anybody else ready to share there? Anybody else? I'm going to just come over and make you get it. Oh, no. You have something. Oh, this is cool.
Oh, that looks cool.
Yeah, that looks very cool.
Okay.
What's your name?
Sabrina.
Sabrina. And what's this you got here? Here it is, you guys.
Well, I was thinking like a ball with legs or something.
Yeah.
And then like a little box right there so I can like keep the stuff in there. Like collect items.
Yeah, collect the items.
Yeah.
Now, is it stripes anything specific or just like a cool design you
Just
like?
like the cool design.
Very cool. I like this. Very nice. Good job.
Thank you.
You know, we're looking at things like that too, where maybe we keep rocks and then try to bring them back to Earth so we can understand them here. So
One more? Anybody? One more person want to show off there? Just look. He's over there working.
Yeah.
That's my boy. Come on. You gotta tell us. You gotta tell us. Please stand up. What's your name?
Robert.
Robert. Okay. Ooh, this got loud real quick for you. Okay. See, now here, reminds me of Lord in Space. Y'all remember that show? This is cool. Can you tell us about it, Robert?
Well, it like has hands to pick up rocks,
Mm-hmm.
and then like buttons, so, like if it wants to like talk to people in Earth. And
Yeah.
then wheels to like move around and stuff for different like type of surfaces and stuff.
Really cool. I like this a lot. You did a good job. All you guys did a great job. Very cool. Alrighty, those are some great ideas, you guys. Some very good STEM-based thinking. So, Bobak, how did you and your team come up with the best, how did you guys pretty much deal with this challenge?
Well, I think I explained a little bit earlier. We were trying to understand what we would have to drive over, and we knew we could land on. We landed in actually a really awesome place. It's this crater with a mountain, so we could land on different types of slopes. We had to make sure we could drive up, kind of slopes. We had to make sure that if there were rocks that were large in our way, we could drive around them, or if the smaller rocks, you just want to drive over them and save time. So we came up with the idea that 6 wheels, and like I said, any one wheel can go up over a rock, for example. That also means that while you're on a slope, you have a little bit more stability because you have more wheels to make contact with the surface. But that being said, we have all sorts of designs. This is an athlete design here. This is like a 6-wheeled spider that sort of crawls over things. And then we also have Axel, for example, and this guy is meant to kind of go up even steeper slopes. It's just sort of repels itself down, so it like lowers itself down different surfaces. You can go down kind of mountainsides and things like that while investigating them. And this is another example of that sort of design. So we have all sorts of designs based on where we think we're going to go and what we think we want to explore on those places.
Very cool. I think that's really cool. And I wish I was over there doing the challenge with you guys. Seems like a lot of fun. Well, I want to thank you so much for sharing everything with us today, Bobak. You've been great.
Thank you.
And I was right, I think. You do have the best job in the world. And that, my budding STEMers, brings us to the end of our program. Here's one last thing I want you guys to think about. What you're learning about, math, science, engineering, and technology is really, really important. STEM is the foundation for keeping an airplane from ending up burning, or to help cure disease, and for getting TV signals to your house, and for exploring other worlds. It's bigger than just schoolwork. It's bigger than what you do in after-school clubs. It's a foundation you can build on for the rest of your life. The jobs you'll have in the future, or maybe even challenges and jobs that haven't been thought of yet. At all the places that we visited, people are solving these problems every day. They're coming up with new creative solutions, and they're doing it while working at some of the most exciting, fantastic places to work in the world. Like here, NASA's Jet Propulsion Laboratory. Who's going to be the next generation of innovators? You are. So, when we're done here today, take those first steps towards matching your interests to a career where you can use STEM. Start with visiting ionfuture.org, where you can play the Ion Future games and dig a little deeper. Here's a quick look at what you'll find. ionfuture.org. And it's just a click away. We hope you think about some of the challenges you heard today. And even after the show is over, discuss them with your friends, family, and classmates. And practice your STEM skills. Put yourself into the shoes of the people you met today. Someday soon, that could be you. I want to give a big thank you to the Jet Propulsion Laboratory, Rolls-Royce, GlaxoSmithKline, Viacom, and to all of the companies that are part of Change the Equation. Thank you for making it all possible. Goodbye, everyone. Bye. You guys were off the hook. You guys were really good.